So for the FCFS algorithm, the idea was the order in which the processes will be coming in the same order, they will be sent to the CPU for executions. Okay. Now, in that, this is a very simplest algorithm, and for this algorithm, the problem was if somehow the large size, the large burst duration process come in the first, then it will have the waiting time large. The total waiting time and the average waiting time will be very high, because this is called the convoy effect. The same example, if we choose like the shortest processes come in the first and the longest process come in the last, then immediately the waiting time will be reduced. So if you see, for the earlier example, the total waiting time was 27. For this case, the total waiting time is 3. Okay. Average waiting time was 3, and here the average waiting time becomes 17. So that was a thing that happens. Now we have another algorithm called shortest job first. So each process is having a burst time or burst duration, that how much time it requires next by the CPU for its execution. So that is called the burst time. So we will choose that particular process whose burst time is less. So out of the 3-4 process, the process that is having the lowest burst time will be chosen first, the CPU, for CPU executions. Now this can be of two types, preemptive scheduling and non-preemptive scheduling. For non-preemptive scheduling, the process that arrive and having the lowest burst time will be sent to the CPU for execution, and once it is scheduled in the CPU for executions, it will be in the running state till its completion of the burst time. So no preemption. Preemption means forcibly stopping a running process. Preemption means forcibly stopping a running process. So the other one is preemptive shortest job first algorithm. The same algorithm is of preemptive type. So whenever a new process comes in the system, it will check with all the available processes as well as the running processes. Among those whose burst time is less will be scheduled for execution, and for that case, maybe one running process may need to go for preemption. So if a running process is having higher burst time than a new incoming process in the system, then the running process will be forcibly stopped and will be sent to ready queue. This phenomena is called preemption. So shortest job first algorithm can be of two types. It can be preemptive type, it can be non-preemptive type. Dakho, is there any issue with this discussion in our last class?
No, sir.
Next we have priority scheduling. In priority scheduling, each process is associated with a priority number. Lower the priority value is higher the priority is. That means whose priority value is less or smaller, that is having the higher priority. That is the custom. You can think that way this is denoted. So a priority number is associated with each process. CPU is allocated to the process with higher priority. Higher priority means smallest integer. Again, this priority based scheduling can be of two types: preemptive type, non-preemptive type. If it is a non-preemptive, then once a process goes to the CPU for execution, it will be executed till its completion, its burst time. Whereas for preemptive type, If a higher priority process comes in the system, then the lower priority running process will be preempted. Lower priority running process will be preempted by an incoming higher priority process. So that is preemptive type scheduling. Okay, so we will দেখো তো গেছে কিনা হোয়াইট বোর্ডটা? Is the whiteboard visible?
Yes, sir. Yes, sir.
So let us take an example from my book because this is not in a slide. Suppose there are 4 processes. এটা লিখে নাও, হ্যাঁ? Process কি হলো, কালারটা কি হয়ে যাচ্ছে? Arrival time, burst time, and process priority. So there are 4 processes. Let us assume P0, P1, P2, P3. Arrival time are 0, 1, 3, 5. Their burst time 10, 6, 2, 4. Their priority values 5, 4, 2, 0. So this is the problem. We need to schedule this process. Now here you see P3 has the lower value priority value 2, then P2, then P. So if you arrange them in a priority order, so P3 has the highest priority value. Because lower the priority value is the higher priority. So P3 has the highest priority, then P2. Then P2 has the highest priority, then P1. P1 has the highest priority, then P0. So let us first draw with the non-preemptive. So in the same way we will draw the Gantt chart. বলো কি হবে?
So the CPU will be waiting for 5 seconds, sir, and then we'll start with P3.
Sir, we will start with P0.
Sir, we will start with P0 because it arrives at P0.
Yes, we will start with P0 because at the 0th time, there is only one process, no other process is there. You have only one subject to study in this semester. There is no other subjects, no teacher, only one teacher, one classroom, one batch, one exam operating this time. So there is no questions of scheduling. Just 8:15 में आ जाओ, we will start operating system till 5:30. Again tomorrow come at 8:15, we will start operating system 5:30. तुम लोगों को खाना पीना भी नहीं लगता. ठीक है? So there is only one process. That is at the 0th time there is only one process in the system, that is P0. So allow P0 for execution. We are going for non-preemptive type scheduling. So once P0 is in the CPU, it will be in the CPU up to
10 seconds.
10 seconds. Because we are going for
Non-preemptive.
So after 10 seconds, this process gets completed.
So P3.
After 10 seconds, what are the processes in my system?
So P3.
No, first tell me
P1,
how.
P2, P3.
P1, P2,
Yeah.
P1,
P1, P2, P3. Whose priority is the highest priority?
the P3.
P3.
So allow P3 for execution. Again, we are going for non-preemptive. So allow P3 for
4 seconds. 4 seconds.
हो गया? So
Yes.
P3 complete हो गया. Now we have two processes in the system, P1 and P2. Whose priority is higher?
P2.
P2.
Good.
P2.
So P2. If P2, how much time?
Sir, 2 seconds. 16. 2
2 seconds. So it becomes
16 seconds. 16.
ठीक है? हो गया P2. Now I have only one process. There is no questions of scheduling. So put the P1 process from the head of the ready queue and put it in the CPU. How much time?
6, sir.
22.
22.
20. Okay. So now can you draw the finish time? I mean, as per our yesterday in the last class discussion, finish time, then the turnaround time, then waiting time,
Yes.
average waiting time, and average turnaround time. So draw it. বলো কত হলো?
Sir, average waiting time 7.75.
এভারেজ ওয়েটিং টাইম কত হলো ভাই?
7.75.
7.7.
7 point. All you agree with this? And average turnaround time
13.25.
13.25.
25.
দেখো সবার এসছে এটা? হ্যালো,
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
এত?
Yes, sir.
Yes, sir.
No doubt? দেখো, anybody has any doubt with this?
No, sir.
So can I go to the next? Now you take the same example, priority based algorithm, but instead of preemptive, let us move to non-preemptive. Instead of non-preemptive, let us move to preemptive type scheduling. So now you tell me the Gantt chart. বলো কি হবে? দেখতে পাচ্ছ তো আমার? আমি একই জায়গায় ইচ্ছা করে ড্রটা করছি।
Sir, P0 for 5 seconds.
P0 will be for
5 seconds, sir.
5 seconds.
1 second, sir.
Sir, 1 second.
1 second.
1 second, sir.
P0
So
will
1 second, right? Then P1 will come up.
P1 is there, right?
Yes. So P0 will be, again tell me, those people who told 5 seconds, why did you tell 5 seconds?
ভুল বলছো।
ভুল বলেছো?
হ্যাঁ স্যার।
বুঝতে পেরেছো তো? কেন ভুলটা বলছো? Okay. So it will be, so at the beginning there is no process. So there is only one process, so let us schedule it. So there is only one process in the system. What is that process?
P0, sir.
The P0.
So P0 will be in the CPU till the next process come in the system. And whenever a new next process will come, we will compare their priority. So after 1 second, P1 come, and P1 has the priority 4, whereas the running process P0 has the priority 5. So what will happen?
So P1 will execute for 1 second.
So P0 will be preempted. Mind it, the term. P0 will be preempted by a higher priority process. So P0 will be preempted by a higher priority process P1. So what is the next burst time for P0?
9 seconds.
9 seconds.
Is the idea clear?
Yes.
P1 will be in the CPU up to how much time?
Up to 3 seconds.
Up to 3 seconds. That is up to
4.
So this become
4.
now what are the available processes in the system?
P2.
My question is what are the available in the processes in the system?
P0.
P0.
Sir, P0, P1, P2.
Sir, all 4 are available.
P0, P1 and P2.
P3 is not available now.
P3 is not.
Arrive at 5.
Yeah. So out of these 3, whose priority is the less? I mean the higher priority?
P2.
P2. So P2 will be there up to how much time?
5 seconds. 2 seconds. 6 seconds. 5. Up to 5 seconds.
Sankita Mondal? কি বললে Sankita?
Sir, up to 5 seconds হবে.
Concentrate here. See, P2 is in the CPU, but at the 4th second, another process is coming whose priority is higher, priority level higher than P2.
Sir, ওটা তো 5th সেকেন্ডে আসছে।
5th second.
Oh, sorry.
P3 arrival time is 50 seconds.
Okay. Sorry. You are right. So it will be in the. ঠিক আছে তাহলে?
Yes, sir.
Yes.
Yes,
Okay,
sir.
Sorry.
Yes, sir.
Sorry. It was my misunderstanding. So P2 will be not in the system anymore. So now again context switching. P0, P1, P3, 3 process. P0, P1, P3. So which one should we settle?
P3.
P3.
P has highest priority.
P3 has the highest priority. P3 कितना तक रहेगा?
Up to 9
9
seconds.
seconds.
Up to 9 seconds.
Yes, yeah. So 5 plus 4, 9. So no more existence of. Now what are the processors in my system? P0 and P1. Whose priority is the highest priority?
P1.
P1.
What is the remaining time of P1? Remaining
4
burst time?
4 seconds.
So
13.
4. ঠিক আছে?
Yes, sir.
So P1 is also completed. There is no more process. Only one. That is P0. And P0 will be
9 seconds. 9 seconds.
So again, average waiting time and turnaround time.
Sir, average waiting 4.5.
Average waiting time
4.5.
and average turnaround time
10 seconds.
দেখো এগুলো এসছে তোমাদের সবার? সংকিতা এগুলোই এসছে প্রযুক্ত
অ্যাভারেজ ওয়েটিং টাইমটা কত বললেন? মানে আমার 5.5 আর কত আসছে?
ইয়ে হর্ষিত বললো 4.5 হর্ষিত 4.5 বলা
Yes, sir.
तो एक बार चेक
আমি
करती हूँ मैं।
আমি
तो एक बार
ক্যালকুলেশন
चेक करती हूँ मैं। एक
না আমি ক্যালকুলেশন কিন্তু করিনি যা তোমরা বলছো আমি সেটাই লিখছি কিন্তু হর্ষিত সপ্তমী কত গেল গো
স্যার দেখছি
4.5. 4.5, yeah.
हाँ सर 4.5 আসছে।
অপুরি
Yes, sir, yes.
what is average waiting time
4.5.
and average turnaround time
10 seconds.
okay so all you agree
Yes, sir.
yes
now from these two Gantt chart one is for non-preemptive type another is for preemptive type for the both the same priority based scheduling algorithm. Now can anybody say what is the total number of context switch for both the cases? What is the total number of no, for the first case
5 in preemptive type.
so 5 in preemptive and 3 in non
5 in preemptive 1 2 3 4 5 and what about this
3
3 in non-preemptive.
so 3 context switch for non-preemptive and 5 context switch in preemptive, right? All you agree?
Yes sir.
yes sir
Now listen very carefully. Performance wise preemptive is giving you better result because it gives you better average waiting time, average turnaround time. Lesser the waiting time, better it is. Lesser the turnaround time, better it is. So basically if you go for preemptive type scheduling, then your performance is better in comparison with non-preemptive type scheduling. But one thing we are not considering. What is that?
sir the operation time for scheduling by the priority queue that would be
Context override of context
Exactly
switching.
operation time. Rather more specific term I want to listen from you. বলো তোমরা বলতে পারবে I know you can any of you can very casually you can tell. What
Context switching time to shape the PCB.
Yes, Vishal, very good. So we are not considering context switching time. Both the cases we are not considering context switching time, but in any operating system there is a significant amount of time it requires for context switching, and during context switching there is no useful execution or any instruction execution is being done by the CPU. So if you go for repeated context switching, then it degrades the performance of the system. So in other way, in one side, if you go for context switching, then the degree of multi-programming will be increased, your performance may be increased. But on the other hand, you need to incur the context switching overhead time. But for our example, we have not considered, for simplicity, we have not considered the context switching time, but there must be a context switching time. Is the idea clear?
yes sir
Bolo.
Yes, sir, yes, sir.
Yes, sir.
sir but it may be that in the queue there are millions of processes there So finding the lowest priority process would also take some, some time by the priority queue. Won't that to be also added in the result? Because
that will not be considered here. That will not hamper the, because once it is in the ready queue, from there we are considering the choosing a process from the head of the ready queue to send it to the CPU for execution. But while it is doing context switching, that time CPU is halted. During context switching, the CPU is halted.
okay,
Can you remember the example that I have given in my class while discussing or while giving the concept of context switching? What example I have given? Can anybody say? With your daily life?
The common bikes are in the hostel.
Common?
Bike in the hostel. Sir.
common.
Sir, changing administrative buildings, academic buildings.
So you have 4 classes in the first step, 4 theory classes. One class in the administrative building, another class is in the main academic building, another is the CSC block, another is in the IT block, another is in the DMs and hall. So after every class you need to switch from one physical location to another physical locations. And what you people will be doing? If it takes 2 minutes, you definitely take 10 minutes. And we will be saying to the next teacher, कि सर वो सर ने देर में छोड़ा हम लोगों को. So you see, up to 4 classes, first, second, third, fourth, there are 2 context switching will be there. There will be 2 context switching from first class to second class and second class to third class. So 3 context switching. So if I consider 10 minutes, 10 minutes, 10 minutes in each context switch, so 30 minutes मेरा चला गया. So out of the 4 classes in the first half, the 30 minutes will be wasted of no what. Because during this shift, during your shift from one classroom to another classroom, no academic activities will be done. So that is an overhead. That is an overhead in the academic curriculum. So that's why we prepare the class routine. Normally all the theory classes are kept in one side. Maybe first period, second period, third period, fourth period. Second half is entirely lab. Or first period is a theory class and second, third, fourth is a continuous lab. Or maybe all the first of 3 classes is in the lab. Such that the number of context switching from one classroom to another classroom is as minimum as possible. Have you ever seen this? I mean, our routine क्या ऐसा हम लोग करते हैं to avoid unnecessary wastage of time. After 5:30, what do you do? We don't bother. Before 8:15, what do you do? We don't bother. But during the session from 8:15 to 12:15 and from 1:30 to 5:30, we normally keep all the classes in a consecutive class. I mean, in the same classroom or in the same lab. To avoid unnecessary wastage of time. Even so will you try it again? This problem with the context switching time 2 milliseconds. Pure.
Sir, we can try.
Sankita,
হ্যাঁ স্যার ট্রাই করে নেক্সট ক্লাসে বলবো
next class বাবা
স্যার এখনই করছি তাহলে
এই প্রযত অপুরি
করছি স্যার
হর্ষিত
Yes, sir.
আদিত্য
Yes, sir.
বাকি ছেলে মেয়ে বলে গেল কোথায় গিয়ে আনে क्षितिज कहाँ गया आज हितीश,
यस सर।
कहाँ चला गया तुम आज?
कहीं नहीं सर, यहीं पे हूँ।
चुप हो गया क्यों? अभी नींद से नहीं उठा क्या? रिसर्च नहीं छोड़ा? हाँ,
नहीं सर, ये अभी तक तो हो रहा था। अभी ये वाला भी ट्राई कर सकते हैं जो आप बोल रहे हैं।
yeah. So
मिलीसेकंड।
take the same example. Consider the priority-based scheduling both for preemptive and non-preemptive, but along with that, you associate a context switching time of 2 milliseconds. ठीक है? Bornally घोष.
Sir,
हाँ, बोलो. हर्षित बोलो.
sir, like, if we are switching from one process to another process and switching time is 2 seconds, and in between some other process with like higher priority comes, then we will again switch.
ये confusion हो सकता है. So you consider only one context switching there time.
Okay, sir.
But 2 milliseconds, sir.
हाँ, बोलो. बोलो.
So context switching time 2 milliseconds, sir.
2 milliseconds. 2 milliseconds. Context switching time 2 milliseconds. Bornally घोष. मशीन को पली गए. ईशान कहाँ गया है? ईशान दत्त
सर यही है, ट्राई कर रहे हैं अभी।
ट्राई कर रहे हो?
हाँ सर।
सागर अग्रवाल. सागर अग्रवाल. प्रीति दास. प्रीति दास. कुलदीप गौतम. साढ़े सात दिच्छे ना केन तोमरा? निखिल कुमार.
यस सर।
क्या हुआ? हो रहा है?
हाँ सर।
पूनम किसको?
Sir. Yes, sir.
Are you doing?
Yes, sir. Right.
Okay. प्रसन्न.
हाँ सर।
क्या तुम चुप बैठ क्यों रहते हो?
सर कर ही रहा हूँ, दूसरे जवाब दे
तो
देते
बात
हैं।
करने में बात सुनने नहीं दिया. देखा मैंने. आज घर में हो या रास्ते में?
नहीं सर, घर पे मैं ट्राई कर रहा हूँ कॉन्टेक्स्ट स्विचिंग।
ट्राई करने का क्या है?
सर प्रीएम्प्टिव वाला ट्राई कर रहा हूँ सर। वही कंफ्यूजन है कि अगर कॉन्टेक्स्ट स्विचिंग बार बार होगी तो उस टाइम पर
कंसीडर वंस
01 at 21.06 seconds, sir.
बोलो राजिता.
Sir, 22.01 for preemptive and 22.06 for non-preemptive, sir.
মানে আমার কাছে আনসার নেই. ঠিক আছে, আমি লিখছি, তোমরা বলো যা যা হবে হয়তো. আমার কাছে তো আমি পড়িনি.
But total time 22 seconds. Number of context switch in case of preemptive is 5.
Non-preemptive. Preemptive.
So in non-preemptive we have 3 context switches, so 3 into 2 milliseconds.
Total waiting time. Total turnaround time. Then average waiting time. Average turnaround time. বলো কোনটার ক্ষেত্রে কি আসছে?
Oh no, I'm going to put it in. Sir, 1 second, sir.
Sir, for non-preemptive, total turnaround, like average turnaround time is 16.25.
16.25. দেখো তো এইটা
Sir, average turnaround time.
average turnaround. कितना बोला 16.25?
Yes, sir.
अच्छा, और वेटिंग टाइम?
Average waiting time 10.75.
देखो तो सवाल ये इससे भी प्रीएम्प्टिव में करते हैं। अच्छा,
Preemptive कर रहे हैं सर।
अच्छा, it is
It's a preemptive doing preemptive one. सर मतलब होगा क्या, मतलब हर P0 P1 के बीच में 2 सेकंड का एक वो आ जाएगा।
एग्जैक्टली जब भी कॉन्टेक्स्ट स्विचिंग होता है बीच में मानो कि
मतलब between every two processes we will have a gap of 2 seconds.
Yes. So मानो this is P0, so यहाँ पे एक कॉन्टेक्स्ट स्विचिंग हो रहा है, then P1, so यहाँ पे तुम एक कंसीडर करो 2 मिलीसेकेंड, फिर मानो कि यहाँ पे अनदर कॉन्टेक्स्ट स्विचिंग P3 आ रहा है, so consider another 2 milliseconds. So this is the overhead.
सो नॉन प्रीएम्प्टिव के साथ डायरेक्ट 2.5 ऐड नहीं कर सकते?
डायरेक्ट ऐड করে দিলে কিন্তু হবে না বিশ্বজিৎ, ডাইরেক্ট অ্যাড করে দিলে কিন্তু ভাই হবে না। সংগীতা করছো?
স্যার প্রিএমটিভের অ্যাভারেজ ওয়েটিং টাইমটা কি 7.25 আসছে?
বাবা আমার কাছে আনসার নেই গো, আমি বলছি তোমরা মানে তোমাদের
স্যার
কনফিউশন।
আমার প্রিএমটিভের অ্যাভারেজ ওয়েটিং টাইমটা 7.25 আসছে আর অ্যাভারেজ টার্ন অ্যারাউন্ডটা ক্যালকুলেট করছি স্যার।
अच्छा, ये हर्षित किया क्या?
सर अभी कर रहे हैं।
আমার কাছে আনসার নেই রেডিমেড, সো হাউ ক্যান আই টেল? আমাকে তাহলে করতে হবে তোমাদের সাথে।
স্যার একটু কনটেক্সট করে একটু ক্যালকুলেশনটা দেখালে সুবিধা হতো স্যার।
আচ্ছা ঠিক আছে, ঠিক আছে, তাহলে তুমি আমাকে জ্ঞান চার্টটা একটু বলবে পর্যন্ত? আমি তো সব প্রিএমটিভ এর ক্ষেত্রে দুটোর ক্ষেত্রেই।
আচ্ছা স্যার, নন প্রিএম্পটিভ এর ক্ষেত্রে স্যার তো P0 তার মাঝে একটা ওয়েটিং।
তাহলে আমাকে একটু বলো, তুমি একটু ডিকটেট করে দিলে আমাকে। আমি তো ওইগুলো মুছে ফেললাম, ইচ্ছে করে আমি ড্র করবো বলে মুছে ফেললাম। প্রিএমটিভ নাই নন প্রিএমটিভ কোনটা করবো?
স্যার নন প্রিএম্পটিভ ফার্স্ট।
So I am drawing the Gantt chart for non-preemptive. हर्षित तुम भी देखना थोड़ा, हाँ?
Yes sir.
Because I don't have the data.
So P0 for 10 seconds sir first.
First P0
for 10 seconds. 0 থেকে 10.
কেন হায়ার প্রায়োরিটি ওটাই নাকি?
না স্যার,
PM non
মানে
ওটা
ওটা নন প্রিএম্পটিভ।
হ্যাঁ রাইট 10 second. Okay, next
sir 12 for 10 plus 2 milliseconds we have
Context switch.
so it will start from, so it already 12 चला गया, ठीक है? What is the next process?
sir it is 12 milliseconds sir, 2 milliseconds sir.
হ্যাঁ ও আমি সবগুলোকে কনসিডার করছি একই ইউনিটে, মিলিসেকেন্ড। Sorry. All you consider milliseconds. Sorry. Maybe there is a mistake from my end. All you consider in the millisecond.
এরপরে P3 আসবে, তো that will be completed in 16 সেকেন্ডে ওটা কমপ্লিট।
What is the duration of P3?
4 seconds.
So it will be 4 seconds in 16, right?
হ্যাঁ,
So repeat again.
তো তারপরে আবার 2 সেকেন্ডসে কনটেক্সট সুইচিং হবে, তো ওটা 18 হয়ে গেল। তারপরে আবার P3 আসছে, P3 will be
কি আসবে?
P2 sir. P2 comes for 2 seconds, so it will be completed in 20 seconds. 20th second complete হচ্ছে P2.
Then
again 2 seconds context switching মানে 22 হয়ে গেল, তারপর p1 আসছে for 6 seconds. So p1 comes তো 22 plus 6 becomes 28 second এ পুরোটা কমপ্লিট হয়ে যাচ্ছে।
Yes, that's it. After 5:30, sorry. After 5:30, somebody may go to the hostel, somebody may go to the jobs, somebody may go to the city center. We don't bother. So we will consider only up to 5:30. After 5:30 p.m., some may be going to the jobs, some may be going to the maybe Biari Gate, some may be going to the Sidhu Kanu Stadium, some may be going to the gym. We don't bother. So during 8:30 to 5:30 we will consider. We don't want the wastage of time. We have to make the schedule in such a way that in between time should be minimized. So before 8:15 we will not consider. After 5:30 we will not consider. So context switching here, context switching here, context switching here. Okay. So P0, arrival time 0, arrival time you already know. So finish time for P0 is 10. All you agree?
Yes, sir.
Yes, sir.
Finish time of P0 is 10. Finish time of P3 is
60,
16. Finish time of P2
20,
20. Finish time of P1 is
28.
28. So you have the arrival time, you have the finish time, you have the burst time. You can calculate the waiting time, you can calculate the turnaround time. Follow. Where is the confusion? পর্যন্ত ক্লিয়ার হলো?
হ্যাঁ স্যার।
You apply the same logic for preemptive also. Apply the same logic for preemptive also. So for the context switching is concerned.
Sir, in preemptive, sir, same confusion is there. Like, sir, if we do in one way, like, sir, 3 context switching are there only in preemptive also.
Okay. So is this clear for non-preemptive?
স্যার তাহলে স্যার একটা ডাউট ছিল স্যার, তাহলে তো ইন কেস অফ like if you are introducing context switching timing, sir, that won't have any effect on the turnaround time, sir, because turnaround time is finish minus arrival. So the finish times are still are same as without any context switching.
No. No. For earlier case context finish time P3 কত ছিল? 14 ছিল। দেখো তো।
আচ্ছা 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 হ্যাঁ।
Similarly for P2 it will be changed, for similarly for P1 it will be changed, because that overhead will be added to all of them.
Yes sir, preemptive में वही डाउट हो रहा है कि while context switching another higher priority process is arriving, so how will we decide which
Yes,
one
sir.
which one will go?
Let us draw, don't worry. So ये समझ में आ गया तो?
Yes sir.
Yes, sir.
इसमें कोई डाउट है क्या?
नहीं सर, ये समझ आ गया।
Anybody has any doubt with the non-preemptive? বলো, পরিষ্কার করে বলো আমাকে, নাহলে আমি বুঝতে পারবো না। তোমরা না বললে আমি কি করে বুঝবো? আদারওয়াইজ আমাকে জাস্ট সিম্পলি ইউটিউবের মতো পড়িয়ে যেতে হবে। প্রিএমটিভটা করছি, হ্যাঁ, তোমরা ডেটাগুলো দেখবে একটু। আই ডোন্ট হ্যাভ দ্য ডেটা রাইট নাও, আই মিন দিস দ্য এন্টায়ার ওয়ান। So at the 0th time,
P0.
P0.
For 1 second.
1 second.
For
1 second.
1 second. So after 1 second,
2 seconds.
context switching.
Context
another
switching.
process comes whose priority is P1.
Yes, sir.
Yes, sir. Priority 4.
Priority is P1. So and that is P1. How much time P1 will be there?
2 seconds.
2 seconds.
Sir, when P1 starts, P2 with the higher priority is already in like a list.
Yes, sir. P2 is already, so
10
P2
seconds.
should be there na in the second one.
Yes.
So again we will switch.
Yes. So actually यहाँ पे एक ही context switching करके इसको P2 कर दो.
सर एक ही context switching कैसे होगी सर? So just because in context switching we like copy paste data.
मतलब इसमें अगर दो context switching कर सकते हो, I mean there is no hard and fast rule in the book because if you allow P1 for execution, the moment it start executing, another process come in the system. So immediately it will be context switch.
Sir, then
So
additional
another
2 seconds will be required for context switching from P1 to P2.
Yes. So maybe you can consider another time. So by that time, another process will be coming. So this example will not actually it will happen. I mean, we need some better example. So you can take this one. But if you consider this, so all
Again,
the
sir, context switching.
Another context switch.
Again, and context switching. P3 will return.
Yeah. You have to come up with some better example. But anyway, so at the end, what I want to mean, while if the context switching time is given, you cannot neglect it. Whenever there is a context switching, you have to put context switching time. Okay, I will come up with some better example for you. Okay, don't worry about that. But the basic concept, whether the basic concept is clear or not, that is more important. Typically, for this particular example, the context switching is becoming repeatedly. So that is not the practical one.
Sir, I think context switching time should be very less as compared to the process execution time. Means there should be some criteria over the context switching time, right? So that we can eliminate this kind of.
No. See, burst time. The burst time is decided by the programmer. That what are the instructions is in your program. Whether it is an IO burst or CPU burst, whether the instruction is looking for some kind of IO device or it is looking for some kind of CPU cycle. So that decides whether it is a IO burst or CPU burst and what is its duration. But on the other hand, the context switching depends on your system architecture. How much time it takes for loading and saving it to the PCB. So for the context switching duration is concerned, context switching overhead is duration overhead is concerned, you as a programmer, you don't have any authority to change it.
Okay, sir.
It depends on the hardware architecture.
Sir, but definitely the design should be such that the order of time that is taken by context switching should be definitely less than the order of time taken by burst time and all.
That you cannot say. Because the burst time is decided what type of instructions you are putting in your algorithm, in your program. I mean, with 100% certainty, you cannot say like this. In some case it may happen, but you cannot say like this.
So can two processes have the same priority?
Yes, yes, that is true. Two processes may have the same priority, and in that case, we will call it as a tie. We will call it as a tie. There are two mechanisms. The first mechanism to break the tie is FCFS. Consider the arrival time and give the preferences whose arrival time is earlier to break the tie. Even if their arrival time are also same, then you can choose arbitrarily. You can choose random one to break the tie. Can anybody say what is the issue with priority scheduling? What is the drawback of priority scheduling?
The repeated context switching.
Context switching will be there for shortest job first even also. I mean, context switching is not limited with the priority-based job scheduling, or whenever there is a job switching from one process to another process, whether it is a shortest job first or even priority-based scheduling, there will be a context switching time.
But
even for
a large enough processor, like a process with a large enough burst time, which has a higher priority than a process with very small burst time, but lower priority. So in that case, the lower priority process might never get to be executed. So
this is called
starvation.
Yes, পড়লে নাকি?
না আগে পড়েছিলাম।
দেখেছো? লোকজন আগে আগে পড়ে রেখে দিচ্ছে। It's called starvation. If there is a continuous incoming flow of higher priority process in the system, then the lower priority process will never get the chance to be executed by the CPU. This is called starvation. So the lower priority process will be in a starvation condition. It will never get the chance to be executed by the CPU. This is called starvation. So whenever you go for priority-based scheduling algorithm, it may so happen that there is a continuous flow of high priority process, and the low priority process are not getting the chance to be executed by the CPU, or they are not getting the chance to get CPU cycle. Then this situation is called starvation. That the lower priority process goes to starvation. This is a drawback of priority-based scheduling algorithm. To overcome this, there is a mechanism called aging. As time progresses, the lower priority process, the operating system will increase the priority of the lower priority process. Increase the priority of the lower priority process. That means the priority will be changed dynamically. If the lower priority process is not getting the chance to be executed by the CPU for a long, then the priority of the lower priority process will be increased to some extent, such that they will get chance for execution.
Sir,
So
just a
priority would be
question out
decreased.
here. The priority value would be set by the user, right? The CPU does not have the it does not have the opportunity to set the priority value for a particular
Yes.
job.
Yes. You are right. Only thing is if the lower priority process, in that case, the lower priority process will not get chance for a long time. Lower priority process will not get, if this is the case, that means it is a context. For example, you are in the hostel, in the ID dinner, and you are waiting to take the dinner in the from the mess, and you are sharing hostel with your senior, maybe third year senior or second year senior. So the moment you go to take the food, you saw that somebody is waiting behind you who is in second year or third year. So what you will do is a normal custom that you give the preference to your senior. So you thought, okay, let allow the chance to my senior and allow him to take the food. The moment you see that he take the food, another senior comes. Next you thought, okay, let us give the chance to the next senior. The next moment you saw that another senior come in the picture. So for a long time, you as a junior, you are not getting the chance to take the food. So this situation is called starvation. Now, some of your seniors saw that this small junior is waiting for a long and giving as a custom, he is giving preferences to his senior. So some of your senior come forward and ask you, okay, you take. So this you can consider as aging. So aging is a mechanism. Aging is a mechanism to come out from this starvation situation.
Sir,
বলো।
sir, sorry to interrupt, sir, but আমাদের ক্লাস আছে স্যার এখন actually.
আমার ক্লাসের সময় তোমাদের কোনো ক্লাস থাকে না, তখন 11:15টায় ঢুকছো, 10:10টায় ঢুকছো। আমার ক্লাস ছাড়া কি আমি এত বাজে পড়াচ্ছি নাকি তোমাদের?
না স্যার, actually ক্লাস আছে সেকশন ZS স্যার, TBMS.
ঠিক আছে, চলো, ওকে, বাই।
থ্যাংক ইউ স্যার।
ঠিক আছে,
থ্যাংক ইউ স্যার।
হ্যাঁ, বুঝতে পারলে ব্যাপারটা?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
সংকিতা বুঝতে পারলে? হর্ষিত समझ में आया?
হ্যাঁ স্যার, কিছু জায়গায় প্রবলেম হচ্ছে, তো দেখতে হবে বলে আরেকবার।
আচ্ছা, আমি নেক্সট ক্লাস আরেকবার রিপিট করব। ক্ষিতিশ, সব পেরেছি?
हाँ यस सर, अंडरस्टूड।
ठीक है, चलो, ओके, बाय।
थैंक यू सर।
ओके, थैंक यू।